All right, this is a continuation of the previous video, which was the adult primary brain tumors. Now we're talking about childhood primary brain tumors. And again, by way of review, primary means that it originates from the cells in the brain as opposed to metastatic or metastic, whatever you say that word, tumors that come from some other place and end up in the brain. It's the metastatic, the metastasis ones that are the most common in the brain, but they're not primary. Okay, they started somewhere else. They're secondary, but they're the most common ones that are in the brain. So we already talked about all the different adult ones, but I actually found that I missed one. So before I actually go into the childhood primary brain tumors, I'm going to mention one here, and I want to make a specific point that this is, the first one I'm talking about here is actually an adult primary brain tumor, but I just missed it in the last video, so I'm fitting it in here. And the way you're going to remember that it's an adult one is because it has the word He-Man in it. And everybody knows that He-Man is clearly an adult, okay? So it's Hemangioblastom, okay? So this is an adult tumor, but I'm mentioning it first because I missed it in the last lecture. So this is usually a cerebellar tumor. Okay, so if you remember the different parts of the brain, hopefully you know where the cerebellum is. Uploading my last video here. Let's see, brain. Goodness, brain. All right, so here's brain, and if you look at this brain here that's about to show up, you're going to find that this back part here, see that? That's called the cerebellum. It really helps with not falling over and having coordinated movements. Okay, so remember that. You'll know that this is a Hemangioblastom. You think He-Man was a warrior, so he must have had to have a really good cerebellum to be able to, swing his sword around and not poke the wrong person or whatever. So, all right, that is a Hemangioblastom. And it's often associated with Hippel-Lindau syndrome. And I don't actually remember what the heck Hippel-Lindau syndrome is off the top of my head, so I'm going to look it up with you right now. So if you don't know, you can find out at the same time I do. I should know what that is, but it's escaping my mind at the moment. So Hippel-Lindau syndrome, a hereditary condition associated with oh, okay, cool. Which are blood vessel tumors of the brain, spinal cord, and the eye. Okay, so it's just basically tumors. All right, great. That's not super helpful, but there you go. So it's associated with that. Tie those two together. Maybe you could think of He-Man riding on a hippo or something. I don't know. And but it has to do with retinal angiomas as well. So kind of tie that together. Here's kind of some pictures. Probably one of them. Oh my gosh. Okay. Hopefully. Whew. Here's a retina, so think of it being a retinal issue here. Okay, so the Hemangioblastom, it can produce erythropoietin. Okay, erythropoietin is something that triggers your red blood cells to make more of it. So this might be something that could cause polycythemia, which is like having too many red blood cells. Okay, so these guys produce that, which results in polycythemia. Okay, so it's a secondary polycythemia. This is from another cause. Histology, you're going to get these closely arranged, thin-walled capillaries and minimal intervening parenchyma. So maybe we can find a good picture of this guy on here. Hemangioblastom. Hopefully we'll have, okay, so here's a picture of the Hemangioblastom. And, yep, the way they describe this, I'll read it for you again. Closely arranged, thin-walled capillaries. So here's a blood vessel capillary. It's a thin-walled, whatever, with minimal intervening parenchyma. So there's not much parenchyma between these guys. All right, got it? Good. Let's move on. So now we're going to jump back, and we're done talking about our adult primary brain tumors. Now we're going to talk about childhood primary brain tumors. This is a really awful subject for me, a really difficult subject, I think for everybody. Nothing sadder than that, just about. Okay, so the first one we're talking about here is a pilocytic astrocytoma. So let's look up what this looks like first on, oh, don't want to do that. There we go. pilocytic astrocytoma brain tumor. So that'll give us a good gross picture of what these look like. Remember, this is a childhood one. Oh, so sad. Oh my gosh. All right. So pilocytic astrocytoma. This one is actually in the cerebellum, it looks like. That looks like cerebellum to me, I can tell, because it has these like really tight-looking gyri, which is kind of unique to the cerebellum. This person obviously did not survive the disease, since we're looking at a cut of their brain here. So this first one here was the pilocytic astrocytoma. And it says usually it's well circumscribed. That means you can see it's not really mixing in with the stuff around it. It's got this really defined border around it. They call it well circumscribed. In children, it's most found in the posterior fossa, so back in the back there, for example, by the cerebellum. It may be supratentorial. So there's this tentorium in the brain. It's kind of like this big piece of fibrous tissue, and things above it they call supratentorial, and things below they call infratentorial. Here's the whole brain. Okay, here's like an eyeball, whatever. So sometimes it can be up here, but a lot of times it'll be down there. It's GFAP positive. Now remember, if GFAP, that was one of the things that stained in astrocytes. So do you remember the other one that stains with GFA positive? Glioblastoma multiforme. Okay, that was a grade 4 astrocytoma, and that was the one that was also GFA positive because it's also an astrocyte. So this is an important distinction here. Probably going to show up on the boards. GFAP positive. You're going to get an idea of what it is. These ones are benign, other than the fact they press on stuff. That's not good, but they're not going to it's not going to grow to kill you most likely. It has a good prognosis. Take this out, the person's probably going to be okay. All right, so that's good news. I'm glad to hear that. So that most likely this picture of the child there was showing, hopefully it looks like she turned out okay, thank goodness. It's a solid, it's a cystic plus solid gross. Okay, nice to know. One thing it mentioned here is the Rosenthal fibers. Okay, Rosenthal fibers is if you look at on histological examination, I'm not seeing any Rosenthal fibers here. So let me pull up a picture of some Rosenthal fibers that you can see what they look like. And maybe that's them, I don't know, but that's not the picture from what I'm used to. Rosenthal fibers. Yeah, this is the picture that I'm used to looking at. So these Rosenthal fibers are something that you'd see. I think they're common in a number of different diseases, but they're the common thing with this particular pilocytic astrocytoma. Okay, so done with that one. Next one here for childhood primary brain tumors is the medulloblastoma. So let me write this out for you. I always do that. Medulloblastoma. Hopefully I spelled that right. Looks like I did. Let's get a good picture of what this looks like. Start off with. There we go. Blastoma. Go to our images here. Pull up a good picture. So here are some radiological images. Is that one? Okay. So yeah, here's the medulla. This must be the pons. Okay. So they call it a medulloblastoma, probably because it comes out from the medulla. It looks like it compresses the fourth ventricle. To get oriented where on the brain here, this is the cerebellum. I'm guessing this is the medulla. This must be the pons. So up here would be the midbrain, and then we have the actual telencephalon, the big brain, whatever. Could be another picture. This would be the whole brain here: midbrain, pons, medulla, cerebellum. So it'd be right in there. And right in here, there's this thing called the fourth ventricles. I can get a good picture of the ventricles here. Okay, so get a good picture of the ventricles. Here we go. So there's a number of ventricles here. There's the lateral ventricles. Here's a good picture of the lateral ventricle. Interventricular foramen displayed right there. We have the third ventricle here. cerebral aqueduct coming down here, and then down here we have the fourth ventricle, and it's right here behind the pons and medulla, that area. So what this does is this kind of tumor, a childhood primary tumor, the medulloblastoma, what it's going to do is it's going to grow in here and it's going to press on this fourth ventricle, which is going to cause something called a non-communicating hydrocephalus. Okay, hydrocephalus, hydro, brain, and cephalus, excuse me, hydro, water, cephalus, brain, water on the brain. Okay, there's communicating hydrocephalus and there's non-communicating hydrocephalus. Communicating hydrocephalus is where essentially the water is kind of everywhere around the brain. Too much CSF, it's not like water, CSF. It's everywhere. Maybe there's a meningitis, so it's having a hard time being reabsorbed or something like that. Whereas in non-communicating, it's where one of these areas, one of these ventricles or something is blocked off. Maybe there's a tumor in here somewhere. It's blocking it off, and it gives you a lot of it in that some specific area. Okay, so it's a form of primary neuroectoderm tumor. So primitive neuroectoderm tumor is highly malignant cerebellar tumor. In other words, it really kills a lot of people. It's not a good thing. It can compress the fourth ventricle, causing hydrocephalus. It can send drop metastasis to the spinal cord. I think that means, in other words, that it can metastasize down there to the spinal cord. Looks like with this one you see homer-wright rosettes. I'm going to go ahead and look that up here so we get a picture of what a homer-wright rosette looks like. Homer Wright rosettes and pseudo-rosettes. Oh, goody. Our lucky day. Okay, so the rosette appearance, I'm going to differentiate a rosette from a pseudo-rosette. So rosettes typically are going to be around blood vessels. So if you see a blood vessel somewhere, maybe that's a blood vessel, and you get this kind of like, oh, it's a pretty little rosette going around it. Okay, we should look up what an actual rosette looks like. Rosette. There we go. So rosette's kind of this artsy sort of thing. Yeah, there we go. Here's some rosettes. Look like little flowers. That's a rosette figure. So in histology, they looked at this and they, oh, that kind of looks like a rosette. Yeah, I can kind of see the similarity, whatever. But a pseudo-rosette is one that's not formed around it's not formed around a blood vessel, and a normal rosette is one that is formed around a blood vessel. So you kind of differentiate the two of them there. And I think what they're trying to do here is since it's a neuroectoderm, it's kind of like the ecto is something that goes on the outside, so it's kind of like trying to create this almost like dermal tissue in random places. Okay, so inappropriate placing of the neuroectoderm, and yep, that's good there. So next one here is the ependymoma. Goodness gracious, I'm going to write out and you figure out how to speak English. Ependymoma. There we go. Ependymoma. So these are the ependymal cells. If you remember what an ependymal cell is, or ependymal cell, whatever, it's similar to a choroid plexus cell, but essentially what it is it's these cells that line the brain. Maybe I should just type it in so I don't like give some weird messed up definition. This one also is going to have rosettes and pseudo-rosettes, so I'm going to type it in here. So ependymal cells, there we go. So ependymal cells, here's what they look like. So you get the fluid-filled cavity. They're kind of the ones lining it. They kind of protect the brain from it. Get an actual definition. It says the ependyma, whatever, is made up of ependymal cells. Ependymocytes, a type of glial cell. These cells line the CSF-filled ventricles. Oh, there we go. That's a good definition. All right. I was struggling there. So this is a tumor of these kinds of cells, and they can also cause hydrocephalus, which makes sense because they're probably lining the ventricles of the brain. Okay, and these ones do not have a good prognosis. This is going to kill a lot of people, and this one also is going to have those rosettes and pseudo-rosettes. So this is similar to the medulloblastoma, except for the medulloblastoma was not made from the ependymal cells, whereas this one is. All right, and the last type of childhood primary brain tumor is going to be our craniopharyngioma. So, man, craniopharyngioma. Hopefully I spelled that right. This is a benign childhood tumor, may be confused with pituitary adenoma. Both can cause bitemporal hemianopia, most common childhood supratentorial tumor. Now remember, I talked about the brain. We've got here the tentorum, and then we have the lower part down here is the cerebellum, whatever. So this is above the tentorum, so that'd be supratentorial. So if you see something above the tentorum, think, oh, it's up in the cranium, so it must be a craniopharyngioma. So above supratentorial, craniopharyngioma. Below, probably medulloblastoma can be up there too. Pilocytic astrocytoma. Remember that was the one that was, commonly down the posterior fossa, like down in the cerebellum. Medulloblastoma. Remember that was, back way down there between the down by the fourth ventricle, and then the ependymoma could be, anywhere there were those ependymal cells. Okay, so craniopharyngioma. This is benign. Yay, love to see that. This one's benign. Childhood tumor may be confused with pituitary adenoma. So if you remember the pituitary adenoma, that was an adult tumor that was associated with the bitemporal hemianopia from the previous video. And this is the most common childhood supratentorial tumor. I already mentioned that. It's derived from remnants of Rathke pouch. Calcification is common. So I probably should type in something so you can get some images, associate your brain with this one. So craniopharyngioma. So let's see some pictures of what this looks like. So it's derived from the pituitary gland. So right there it is in the pituitary gland. Yep, good deal. Would have been nice if they mentioned it a little better in the reading. This must be a picture of it. Yeah, that's not what I'm looking for. Anyway, so yeah, there it is. So it's derived from Rathke's pouch. And that concludes our video on childhood primary brain tumors.